Hi, my name is Saba Hena. I'm from Integrity Design and Research Corporation. Today we like to show you a video on how to use one of our Gauss meter model IDR 329. This meter is specifically used to measure the DC magnetic field, or we call it static magnetic field. Typical applications are classify magnets, testing audio speaker magnets, analyze magnetic circuit and components, measure residual magnetic field in the steel. And this model is made in the USA. We offer 2 years warranty on the products. On the front face of the meter, we have 3 knobs: Gauss scaling knobs, coarse and fine. The scaling knobs has a range of 20 Gauss, 200 Gauss, 2 kilogauss, and 20 kilogauss. You select the scale based on the strength of the magnet. The coarse and fine knobs are used to zero out the device. The coarse is for fast adjustment and the fine for tuning. The coarse and fine knobs are used to zero out the Gauss meter. The coarse is meant to use for fast adjustment and the fine for tuning. The left side of the device has on and off switch, and the front side of the device we have 3 outputs. The first output is for DC power supply, the middle one for the input signal, and the right output is for analog output, which has maximum 200 millivolt for full scale. For further information about the DC kilogauss meter model IDR 329, we recommend you to visit our website at www.integritydesign.com. As well, we will ship those information, the data sheet and the instruction sheet with the Gauss meter. You can order the meter with either one kind of probe or maximum 2 probes. This is the transverse probe, this is the axial probe, and this is the ultra thin probe. This is the 3 probe that we provide for the model IDR 329. You can order the meter with either one kind of probe or maximum 2 probes. This is the transverse probe, this is the axial probe, and this is the ultra thin probe. This is the 3 probe that we provide for the model IDR 329. For flat magnet measurement, we recommend to use the transverse probe, which is the sensor is located where there is a black dot side. When you take a measurement, that sensor has to be close as possible to the magnet, or you could press hard for maximum reading. Also, we could use the axial probe to do also this measurement, but it's a little bit inconvenient. You have to put the probe right perpendicular to the magnet. As we said, the axial and transverse probe can be used for same application, but sometimes we do have a magnet, like as with this model here, we have a magnet inside, so the axial probe will do a better job because it has a hole. We could insert the axial probe inside it. The ultra thin probe is also a transverse probe. It has a particular application when we have a gap very narrow, like this reference magnet. The gap is very tiny, so we could use the ultra thin probe to mount it inside that gap. Now it's time to take a measurement. Please follow our operation instruction. Step first, we turn on the meter. The meter will read 1 blank. When you see like this, you mean you have to insert the probe. Sometimes, even if you have the probe and the reading still not shown on the display, we recommend is that something wrong with the sensor. We are still in step 1. Now it's time to connect the probe that we are using. This is a transverse probe and this is the connector. Make sure you handle gently the probe, and there is a little slot here, has to be on the top, and gently push it on the socket of the connector. Now we have a reading on the meter. We are in scale 20 kilogauss. When we need to do the zeroing, we recommend to move on to most sensitive scale. Now we are reading minus 24.5. Also, the meter has a negative or positive polarity indicator. Now our purpose is to have a 0 on the meter. This is the course. We move it clockwise to go higher in the positive measurement, and we are now getting close to 0. Now is the time to use the fine for tuning to bring it to 0 measurement or 0 reference. Now keep in mind, when you do the zeroing, the probe has to be away from any magnetic field. We have the magnet here, so we have to put it away a couple feet away before we do the zeroing. Also, it is recommended if you are in an area like MRI where there is a magnetic field and there is no way you could take the zeroing of the meter, we use a zero Gauss chamber that you will insert the probe inside the zero Gauss chamber for tuning or zeroing your meter. The zero Gauss chamber will shield almost the magnetic field from outside. This is a particular application, especially if you're doing it inside the hospital for MRI measurement. Or, okay, since we are talking about the measurement for MRI inside the hospital, as I mentioned before, because there is a magnetic field all over the area and is no way I could zero out my meter. So the best way is to insert my probe inside the zero Gauss chamber and my meter go to 0. After that, I will slide out my zero Gauss chamber, and the sensor right here, we need to rotate it around till we reach maximum. Here in my location, since there is no magnetic field around me except the Earth's magnetic field, if you notice, if I move my sensor vertical, it will pick up some negative reading. The Earth's field is 500 milligauss or 0.5 Gauss. So this is why when you take a measurement, you may see fluctuation in the meter, but the reading has to be maintained below 1 Gauss or close to 0 before you take a measurement on a magnet. I like also to remind you that the Earth's magnetic field will change from area to area. We are here in the northeast of US. We're looking around 450 milligauss pure if there is no steel or other interference inside your building. Now, as it's very important when you take a measurement in the air or around environment, you need to rotate the probe so the magnetic field has to be perpendicular to the sensor, or sin 90 has to be equal to 1, so to read the maximum. Now we move on to take a measurement around on a magnet. This meter will give you some idea about the Earth's magnetic field, but is not accurate enough as the other model that we do have. It's called model IDR 321, a geomagnetometer, which is reading will be in milligauss. Anyway, I like to mention it because a lot of customers ask me why my reading is fluctuated. So because when you move the probe around, the meter will pick up some of the magnetic field. Now, our second application, how to take a measurement on a flat magnet. This is the magnet, and the magnet has a north pole and south pole, And as we mentioned, that black dot has to be on the magnet very close, or you could put a little bit pressure on it. As you notice, my meter went out of scale because I'm on a scale 200 and I have one dot. I have to move my scale higher and I put it on scale 2 kilo Gauss. Even my magnet is higher than 2 kilo Gauss, I have to go to scale 20 kilo Gauss. So my measurement is 2.44, which is mean 2.44 kilo Gauss or 2440 Gauss. As I mentioned here on my meter, I have scale 20 Gauss, so the reading has to be on Gauss. On scale 200 Gauss, my reading has to be on reading Gauss. When I move it to scale 2K, my reading will be on 2 kilo Gauss. This flat magnet is a standard magnet, and it has one positive side and has another negative side. My meter convention, if you read plus reading, which is the North Pole, and if my reading switching to negative, will be South Pole, and the magnetic field will change on the surface of the magnet very fast because my sensing area is too small. The nominal area is 0.005 by 0.005 of an inch, and usually the magnetic field at the center will be smaller than going to the edge. Or you could have a magnet, it has multipole on one surface. The only thing you could notice it, the meter will tell you the polarity of the reading. This was a demonstration on how to use a transverse probe. Now I'd like to show you a brief description how to use the axial probe. First, I have to unplug the transverse probe. Make sure when you unplug it, never plug it from the cable. There is a handle here, you press on it and you plug it out. Now this is a connector for my axial probe. As I mentioned, you follow the direction of the pin and you insert it to the meter, and you're supposed to hear it clicking sometimes when you put it to the meter. Now this is the axial probe. In general, as we said, we have to zero our meter to avoid a subtraction measurement. Now if we are measuring around MRI, we have to put my probe inside the zero Gauss chamber and I zero it, and I have to go to zero reference. Now my meter is zero, and now I'm ready to take a measurement. You remember I was using that flat magnet. Also, if I have axial probe, I could use it to take the measurement with the axial probe. There is an arrow on the tube here, which is the magnetic field is perpendicular to the sensor. The sensor is located right here. To able to read the maximum, the angle or the orientation of the probe is very important to on the magnet. So to read the maximum, I have to put my probe perpendicular to the magnet, and here you go, I was able to read a measurement. And also, if I'm taking my measurement in the air, so I have to rotate the probe around till I read maximum. And I really recommend, if you're reading, let's say for example, if you're reading less than 20 Gauss, to use the 20 Gauss scale, which will cover from approximately from 0 Gauss to plus or minus 20 Gauss. If your reading is below 200, between 20 and 200 Gauss, I really recommend you to use the scale 200 for better accuracy and less error. If you're reading between 200 and 2 kilo Gauss, I really recommend you to use the scale 2 kilo Gauss. And also, the meter is very linear. So, as you know, the meter is very linear. Let's say I'm giving you an example. I'm measuring on my meter now 1.43 kilogauss. This is on scale 2 kilogauss. Now if I move it to scale 200, I will be able to read Raja. Now also I like to mention the meter is very linear through all the scale. Let's say on my meter right now I'm measuring 29.7 Gauss on the scale 200. If I move it on scale 2K, it will be 0.29 kilogauss. And this is why I told you it's better to use the most sensitive scale so you don't lose a number after the decimal point. Now if I move it to scale 20, my meter will go 1 dot. Also, this is, as we mentioned, this is an axial probe. I have a magnet inside that hole. When I take a measurement, I put the sensor inside that hole, and my meter is going out of scale because I'm in 20 Gauss. If I move it to scale 200, also still the same problem. I move it to scale 2K, the meter will read 1.48 kilogauss because I'm in 2 kilogauss scale, or 1484 Gauss. Now I have a 3-digit after decimal point. Now if I move it to scale 20K, I'm gonna lose 1 digit after decimal point, 1.49. Finally, the resolution on each scale will go multiple of 10. Since the resolution on scale 20 is 10 milligauss, on scale 200 will be 100 milligauss, and on scale 2K will be 1 Gauss, on scale 20K will be 10 Gauss. Also, I like to mention that between the sensor and the magnet measurement there is a copper of 6,000 of inch, and as you know, the magnetic field is very important with the distance. As soon you go away from the magnet, also I like to remind my customer, if they are looking for better precision measurement, I really recommend them to use is a ultra thin probe, because the ultra thin probe, it doesn't have any shielding between the Hall sensor and the magnet, but the life expectancy will be much less than the shielded one. Okay. This is a review about what we've spoken about. First, you turn on your meter and you zero out your meter and you bring a transverse probe, and the magnetic field has to be perpendicular to the sensor. You bring a magnet and you take a measurement. After that, you slide the magnet away, the meter has to come back to zero. Once a while, if you are taking long time measurement, please check the zeroing so often to make sure the meter starts from zero. Finally, if you like for long time usage of the meter, we really recommend you to use the adapter. When you plug the adapter to the electricity, the meter will switch automatically to the adapter mode. And also we have the battery compartment right here to change your battery. Usually you change your battery when you see a value BAT on the display. If you don't change the battery and that BAT is on the display, your accuracy will be diminished. I hope I was able to explain what you're looking for. Also keep in mind the calibration will be valid usually for 1 year, and we charge $95 with data sweep, and we sweep from 20 Gauss using Helmholtz coil up to 14,000 Gauss. And thank you and have a good day.